Welcome to the Math and Science of Fast Food. It's a story of when I first began teaching middle school in a computers and technology class. It's a little bit embellished for storytelling purposes, but I still think that it factually represents the events of the day and also shows how to make a sway, and it's a lot of fun. Without further ado, the math and science of fast food. It began, as so often things do, as a harmless debate between two scholars. It began, as so often things do, in one of the hallowed halls of learning. It began in the cafeteria. First, it was a debate over fries. While the middle school cafeteria was never well known for its stellar cuisine, it did have a small but loyal fan base built up around its French fries. Some say it was the crinkle cut which enabled the consumer better control over the ketchup to fry ratio. Others insisted it was due to the occasional appearance of an abnormally long fry on your plate. Moby fry. Others claimed that the fact that middle school children ordered so many of them, because fries are what hold their molecules together, that this high rate of turnover ensured maximum freshness. The debate over fast food gained momentum when the topic of burgers was brought up. It spilled over the other tables when the topic of milkshakes was thrown in the mix. By the time chicken nuggets reared its controversial head, the entire cafe was in an uproar. The students had found a common thread about which they could all disagree. Is all fast food the same? Is one kind of fast food better than the rest? The following math block was completely disrupted by the residual momentum of the debate. The teacher saw their enthusiasm and realized that this was a teachable moment. The teacher, being wise in the ways of both nutrition and pedagogy, announced that learning mathematics is not something that should ever be confined to the four walls of the classroom. He then said, "Guys, we're going to have to do some research. We're going to have to go to McDonald's." "Yay!" said the children. "On the internet!" Oh! He brainstormed with the kids first. What math or science words do you know about food? The first word students came up with was calories. The second word we came up with was fat. And the third word we came up with was carbs, which we later learned meant carbohydrates. What do we know about calories? Are calories good or bad? Calories are bad, they said. Calories make you fat, they said. The teacher wrote down their ideas without judgment or malice. One girl said, "Wait, don't we need calories? What happens when you don't get enough calories? That's bad too, isn't it?" "It's called starvation," said the teacher. So we all agreed upon the answer that too many calories was bad for you, but so was not having enough calories. What do we know about fat? Is fat good or bad? Fat is bad. Fat makes you fat. The teacher wrote down their ideas without judgment or malice. One boy said, "Wait, don't we need fat? What is the purpose of fat?" The teacher explained that fat is the way the body stored energy, and that your brain and nerves are mostly fat. Fat also gives a lot of flavor and texture to foods. So we all agreed that the answer was, it depends. What do we know about carbohydrates? Are carbohydrates good or bad? One boy from the back immediately shot up his hand and declared, "It depends." "On what?" the teacher asked. "I don't know. I was just taking a stab at it." He equipped them with data points, 2,000 calories and 65 grams of fat. He cited his sources. Then he modeled how his students should use the McDonald's nutrition calculator to find out the amount of calories and grams of fat that were in each item and in each combo meal. Welcome to the McDonald's Nutrition Center. Let's get busy making some meals. First, let's create a combo meal, something maybe we're all familiar with. The kids then experimented with making different kinds of meals. They experimented with serving size and ingredients in meals. They recorded their findings. Then they began to compare the calories and grams of fat of one fast food chain's combo meal to another. Then they looked for similarities and differences, recorded their results, and then tried to look for reasons to explain the results they found. So, this was an example of how I use Sway. If you want to use PowerPoint, bear in mind that people don't want to usually see a lot of text on PowerPoint. And sometimes a document is really important because it contains enough text, but it just doesn't feel very lively as a presentation. Sway is kind of that sweet spot between presentation and document. It's a website, and it's got a lot of tools that can help you embed video, pictures, make those pictures shuffle and have some real pop to them. And I like using it as a teaching tool as well. So, in this way, where I'll embed a link below, you can read the story again if you like, because it's a lot of fun. It's how I used to teach the math and science of fast food to my middle school students, and I taught it to about 1,000 students over 3 years. And this presentation also contains instructions on how to build this way. So, pictures, I say, are worth 1,000 words, and no presentation, pamphlet, or textbook succeeds without good images. So, I think of Sway as somewhere bigger than a pamphlet, but somewhere smaller than a textbook. Give it a shot, and I think you'll find that making a Sway is just another great way to bring lessons to life and to help your students show what they know. I'm James Gill, and this has just been my take on making Sway.